Yes. I once again welcome the lecture series of this microprocessor and microcontroller subject. Okay, today is day 10. The date is May 3rd. So now in the previous classes, last class, previous two classes, and nothing but 8th and 9th classes, we are spending time on the pin diagram of the 8086 microprocessor. But we are not at all complete that one. So today we are going to complete the pin diagram of the 8086 microprocessor. Why we are taking so much time, or why we are spending so much time on this one is nothing but if you know the basics of this microprocessor and all, it is very much easy to understand the entire remaining 4 chapters and 5 chapters. Okay, you know that this is the basic structure of the microprocessor. You know that this is the basic structure of the microprocessor. So what is the microprocessor? Now see this. A microprocessor is nothing but a CPU on a chip. CPU on a chip. Okay, microprocessor is nothing but a CPU on a chip, not the computer on a chip. A microcontroller is nothing but a computer on a chip. Why nothing but this? See this. This is the CPU. So whenever microprocessors want the memory and the input output devices, you are connected in the outer side. Okay, so that's why microprocessor is nothing but a CPU and a chip. So in the previous classes, we are already completed the ALU registers, timing and control unit, then memory, RAM and ROM memory. We are already completed RAM and ROM memories. uh, then uh, uh, then you can see this interface in nothing but pins. Okay, so now see this. So this microprocessor is a 16-bit microprocessor. All the pins and all these things were divided into the three different categories of the pins. So the pins that are common in both maximum mode and minimum mode. So the pins that are available only in minimum mode, the pins that are available only in the maximum mode. Okay, so this is the basic pin diagram of the 8086 microprocessor. It is the 40 pins. Remember, these are the 40 pins. Out of these 40 pins, you are able to connect the each and every memory device. You are able to connect at the same time input output devices only. What is the memory size of the microprocessor? 2 power 20 is nothing but the 1 MB. What is the size of the input output memory devices? It is only 2 power 16. It is only for 64 KB, because here we are using 20 address lines. Here we are using only 16 address lines. Here we are using 20 address lines. Here we are using only 20 address lines, because AD 0 to the 15 lines we are using. But here we are using AD 0 to the AD 15 lines. At the same time, A16 to the A19 lines. So that's why it is 1 MB memory. But input out nothing but for suppose we are able to connect the some pen drive, hard disk or whatever, that memory, that suitable memory that are able to connect to this 806 microprocessor 64 KB. Beyond that one, it is unable to consider the data. Okay, now see this 40 pins. So now see this is the minimum mode pins. These are the minimum mode pins. So these are the maximum mode. The 30 to the pins 30 to the 24 8 pins. These are the maximum mode pins. But remaining 32 pins is common for both max and minimum. Both max and minimum mode pins. 32 pins. So out of this 32 pins, you can see this. These are address lines. Again, these are address lines. You see this AD, A stands for address, D stands for data. Here same also. This is nothing but A stands for address, S stands for status. You know the status of this line. So you know that for the better utility of the pins, better usage of the pins, you are going to use the same pins for multiple purposes. The same pins you can use it as address lines. At the same time, that same pins you can use it as a data lines. How this transformation is available? You know that. So always these pins is available in the address mode. Whenever you want to convert address to the data, we are using in the minimum mode ALE in minimum mode. Then maximum mode it is the QS0 max. So this address lines is converted into the data. ALE means here address latch enable address latch enable. So you know that this is this entire 40 pins we are divided into the three different groups. Okay, what is that? Three different groups here, common signals. So 32 common signals are there for both minimum and maximum. So see this, these signals only different. So all are common. Now see this. These are the 80 to 15 is nothing but the. You know that what is 80 to 15. You know that address and data lines. At the same time, you have the 80 to the S16, S18, S17, nothing but S6, S5, S4, and S3. What is this? What is this? These are nothing but the signals is nothing but a status of the signal. Is nothing but status means here. So it can shows the microprocessor is able to access which memory. It's nothing but you have the segmented memory. You have logically 16 segments are there. So what are that nothing but each segment has 4 categories. Nothing but code segment is 4 different segments are there. It's nothing but codes are 4 segments are available. At the same time, extra segments are or 4 segments are available in the memory. At the same time, data segments and the stack segments are available. You can see this S4 and S3. You know that, or you can identify that Microprocessor is accessing either data or code or stack or alternate data. So you have the BH and BH in bus high enable. You know that meaning high. The name itself it gives some answers. Okay, bus high. High means here high enable or slash S7. So here this is the multi-purpose pins here. Okay, bidirectional at the same time multi-purpose or multiplex. Multiplex means here, remember, multiplex means here the same pins are used for the multiple purposes. You see this, these pins are used for address as well as these pins are used for the data. What is the bidirectional? Bidirectional means here the data we can transmit in two ways. That we can send the data at the same time we receive the data. That is the bidirectional. So you see this bus I enable. Nothing but bus I enable means you know that microprocessor is a 16-bit microprocessor. Microprocessor is 16 microprocessor. Out of the 16-bit, 8 bits are lower order bits. Again, 8 bits are higher order bits. You know that higher. You see this where you are connected this one higher. This is the data bus. This is the data register. A register. So 16 you have 16-bit registers are available. So whenever what are the 16-bit registers available for the data purpose are AX, BX, CX, and DX. Now AX you can also written it as a AL or AH or AL. You know that. BX you can written it as a BH and BL. L stands for lower, H stands for higher. So whenever the data is 8-bit only, on that time we can in the programming for suppose move AH comma 08. H nothing but we are using only higher order. Or move means a copy instruction AL comma 08. This is one type of the code you can write. So nothing that means here the 8 data is copied to the register AH. So on that time, so out of 16-bit only, we are using 8 bits only. Maybe on that time you can add this bus I enable. So this is set. You know that whenever any signal that represents the bar, you can observe these bars. That works as a negative logic. Nothing but 0 is for on, 1 is for half. Remember, half. Yes, you can see this. Yes, you can see this. If this BHE and this lines indicates that lines all and all. Now see this read signal. You know that read means a copy, a copy signal. If this is the CPU, you know that when you read the book, nothing but you gather the information. So this is the memory. Read means whatever data is present in this CPU, nothing but microprocessor. This is read. You know the direction of this. You know that we can see this direction. This direction I draw. If this whatever the data present in memory is coming to that CPU, whenever you want to perform this operation, okay. Okay, that is the read operation. At the same time, we have this write operation is also there in the minimum. Write is also same. Write means here what write you, for suppose you have the book, you write the something, but you store the information on the paper. Yes, it's nothing but see this. This is the write. Write means here send. Read means here copy. Read means here copy or receive. Write means here send information. Whatever the information is stored in the CPU, that is going to the memory or input output device. Ready. You know that ready as uses of the ready. Whenever you want to connect the slow memory device to the microprocessor, you can synchronize between that microprocessor and slow memory device. We are using this ready signal. So then, what is the reset? You know that when you press this reset button, the microprocessor is coming to the initial position. If it is performing any of the operation, once you press that one, so that that operation is stopped at that one, then coming to the initial position. Then you know that interrupt. You have two different interrupts. You know that microprocessor, as I said so many times, microprocessor performance is mainly depends upon the number of interrupts and interrupts. If more the interrupt pins are available, more powerful the microprocessor. Okay, what is the interrupt request and interrupt acknowledgement? You know that interrupt request. You know that microprocessor is performing on operation. You stop that operation and given to the another one. That we can also call it as interrupt request. Once this is accepted, it send the interrupt acknowledgement also. And this is the one another type of the interrupt. You can also call it as a interrupts. You can divide into the two types. Interrupts. You can divide into two types: maskable, non-maskable, maskable, maskable, yes, non-maskable. NMI means a non-maskable interrupt. NMI means a non-maskable interrupt. Nothing but a maskable, non-maskable means it. Whenever you want to write some programming, you want to change the performance and you want to change the functionality of the pins and for suppose, as I said in the last class, for best understanding purpose, a cell phone. If you are playing some games on the cell phone or seeing some watching some movies on that cell phone, whenever a message you got some message, it just show the some notification you got the message and all, it shows something. But whenever you call, you get the call, the entire thing, whatever you are currently performing, nothing but watch the movie or playing that one, so that is stopped and shows that you get that call. So that is the non-maskable interrupt. What is maskable interrupt? A message is nothing but a maskable interrupt. You change that from or you can change some settings to do not show the some messages that are by playing some watching movies and things. But you cannot stop the calls and all whenever you are getting or when you are playing so that is the non-maskable interface. So now another type of the signal is available. Some test signal and series a clock. You know that clock. We have the three different types of clocks. Clock speeds are available in the x86 microprocessor. Three different speeds: 5 megahertz, 8 megahertz at 10 megahertz. Okay, a clock is nothing but a quartz crystal oscillator. Remember, oscillator. Clock is nothing but a quartz crystal oscillator. This is available outside of the microprocessor. Remember, this is not available in this CPU. Nothing but 8086 micro. So this quartz crystal oscillator is available on the outer side. This pins, this quartz crystal oscillator input is given to the this clock pin 19th pin. So this clocks will controls the entire things that is available in the microprocessor. Nothing but this one. At the same time, memory. At the same time, input output devices connected by the connected to the microprocessor. Nothing but the CPU. Connected to the CPU. Okay. So you know that when the clock speed is increases, the speed of the microprocessor is also increases. Now you know that power pins microprocessor is accept or whenever you want to give in on the 5 volts supply to this microprocessor. Then you know that microprocessor is working in two different modes. What are the two different modes? Minimum mode as well as maximum mode. Whenever this is converted into one mode to the another mode, for suppose you want to operate this microprocessor as a minimum mode, it is equal to the 0. Sorry. Uh, Whenever you want to, yes, you see this whatever it may be. Whenever you want to convert this microprocessor from one mode to another mode, for suppose you operate in the minimum mode, that is equal to the 1. Or if it is equal to the 0, it operates at the maximum. You know that one thing you should remember, the 8086 microprocessor is available always at one different mode. Always at one different mode. Please wait. Yes, okay. This always is available at one mode. You know that 0 or 1. You know that if any line is available at 0 or 1, microprocessor work at 1 and 0 zone. If it is 1, work as a minimum mode. If it is 0, work as maximum. If it is always at one of the mode, either maximum or minimum mode. Either 1 minimum mode or 0 or maximum. You know that minimum mode also you can complete in the last class. You know that what is the minimum mode? What is the minimum mode of this one? So this is the minimum mode signals. So interrupts. You know that whenever microprocessor is giving some interrupt request to the any of the input output devices or memory, if it is accepted that interrupt, so that request is given by this 24th pin, that we can call as interrupt acknowledgement. You know that what is ALE, address slash enable. Whenever you want to convert this address to the data bus, we are using this address slash enable. Okay. Yes, this ALE, this data enabled signal, data enabled. So whenever you want to send the data or whenever you want to receive the data from that, sorry, any of the USB ports and all other things, we are using this one. So the next one is the data transmit and receive. You are connected to some input and output or external devices to that one. So whenever you want to transmit the data, you are using data transmit or otherwise nothing but 1 or otherwise you can use it as a 0. So you know that microprocessor is connected. This is a very important one. You know that microprocessor is connected to different types of the category of the device. One is memory and another one is the input and output devices. See this. Microprocessor is connected the memory or input output devices. How you can differentiate this one memory to the how this will be modified the memory to the input output devices. So microprocessor is not able to connect the both memory and the input output devices at the same time, because the address lines for here we are using same, at the same time we are using same. Here we are using AD0 to the 15. The same time then some pins are extra pins you are using A19. Here you are using AD0 to the AD15. The same address lines you are using. Then how to know the microprocessor? Nothing but CPU. The information is available in the memory or input output device. which type of device we are going to access. So that will going to see this one by using the memory IO by number. Memory or input output. If it is equal to 1, it is connected to the memory, or if it is equal to 0, it is connected to the input output. It is 1 memory, it is equal to 0, it connected to the input output devices. Then right, you know that right. Whatever the information is stored in CPU, that is that you are going to save it in memory or input output devices. We are using this write operation, nothing but send operation. Hold and hold acknowledgement. This will be we are using in the DMA, direct memory access. Whenever microprocessors want to access that memory, so it can give the signal hold. If it is access, if the DMA is controller is access that request, it can generate the hold acknowledgement signal. Then coming to the maximum mode signal. Maximum mode signal. So in the maximum mode also we have 8 different signals are available. This D is not available here. See this. Remember, we have 3 different. I mean 8 different pins are available in the. Now see this. These are the pins. 24 to the. These are the pins available. Pins 24 to 31 are the available. Now see this. First of all, 28th and 27th and 26 pins. S0 bar, S1 bar, S2. Nothing but it will 0 is for on, 1 is for off. Nothing but the negative values. You know, see this. We remember this. This truth table are like that table. If this 3 pins are 0, so if nothing but it shows nothing but status. These are all the status signals. Remember, these are also the status signals. If 3 are 0, nothing but it has the interrupt acknowledgement. If this is 0, 0, 1, is 0, 1, 2, 3, 4, 5, 6, 7. If it is 1, it shows the read and input output. It is 2, read output input output devices. If it is 3, all the signal. If it is 1, nothing but 4, access in the code. If it is 5, read the memory. If it is 6, write the memory. It is 7, pass and inactive. You must remember all the things, because at the time of the introduction of the class, I told that is so many times. You just learn what Intel is already developed. Okay. Now see this. Next different types of the signals is QS0 and QS1. Queuing, queue status, queue status. What is the meaning of this queue status? This is very much important one. One of the best advantages while we are using this 8086 microprocessor is a queuing status. And queuing status is nothing but microprocessor is executing the programs one by one. First instruction, second instruction, third instruction, fourth instruction, fifth instruction, and sixth instruction, and so on. This microprocessor, the advantages of the 8086 microprocessor is it can take the 6 interruption instruction. Okay, it can take the 6 instruction commands to the microprocessor at the same time and execute the one by one. It can take the 6 interruption codes from the memory at that time. Remember. So whenever you, for suppose, move AX comma BX, for suppose I can move run this command. This command we can call it as this is one type of the instruction. This you are going to execute the code. So this is the ALP, assembly level language program. Nothing but this is human level language. Nothing but move AX comma BX. You are going to understand, but machine is not going to understand. Okay, this will go to the code segment. An assembler is convert this move AX comma BX into the code 0 or 100 for suppose 1. Where these codes are available in the code segments. These codes are available in the code segments. So microprocessor is not every time go to the code segment means your memory. Every time it's not going to the memory. So then take this codes. So at a time it can take the 6 instruction codes from that memory and execute the one by one. This will reduce as the nothing but the is nothing but the button of the microprocessor. At the same time increases the speed of the microprocessor. Every time it is not going to the memory and come back to that memory and execute that instruction. At a time it can take the minimum of 6 instruction codes from that memory and take it to the some queuing registers and execute the one by one. So now you can see the status of that queuing registers and all. You can see this one. If it is QS1 and QS0 is 00, no operation is 01. So it can operate the first byte. You know that 888 opcode. You know that opcode means an operational code. These are the codes, operational codes. Opcode means operational code. It is 10 empty. Nothing but this queuing register is empty. A 6-bit register here, 6-byte instruction queuing register here. If it is one, it can execute the one by one instruction. So nothing but RQ and GT1, a bus request and a bus grant signals. So now what is this bus request and bus grant signals means here? You know that microprocessor is going to access the microprocessor is connected with so many different type of the devices, nothing but memory and input output devices. Okay, so this different types of memory and input output devices you are considered as the, or you are taking it as the nothing but connected by the buses, a bus address bus or data bus or whatever. Whenever you want to access that buses and all, you want to generate this some request, and if it is generate the request, so if it is accepted, then given it to the Z20. If it is requested and all. So this is the simple way to get that one. Then what is the lock is also there. So then what is the meaning of the lock? An output signal activated by the lock previous instruction. So nothing but if you are microprocessor is performing one instruction. So performing one instruction. Whenever you want to generate the this is equal to the 0, you put this pin is 0. So microprocessor is completed that instruction only, then only it come back to the next instruction or next operation. You can lag that microprocessor to specifically perform one operation data. So when once you generated this one, this interrupts and also is not working. So in the next class we are going to discuss the architecture of the microprocessor. Now this is the queuing list, 6-byte instruction. Yes, okay. So next class we are going to discuss this architecture, how this microprocessor is gather the codes and all, then how the microprocessor is executing the instructions and all. We are going to see in the next class. Okay. Thank you for joining the microprocessor and the microcontroller class. Thank you very much.